So last time we introduced this idea of panel data. We had many entities, but we also had many time periods for each one of these entities. So it was neither cross-sectional data because there were multiple time periods, but it was also not time series data because we had many entities at the same time. This is what we called panel data, where we have many entities through time. And we talked about one particular format for panel data. Cross-section and time series only have one format. Panel data has two formats primarily because we have these two running dimensions, two live dimensions, the entity and the time dimension. What we're doing in this case is talking through a particular data set and some of the limitations of what we called long format panel data, where we have a column for the entity index, and then we have a column for the year index. And then we had our third variable, our first meaningful variable, x. So in this case, this is a data set on coffee consumption per capita across 34 countries over a couple of decades. And we're going to try to explore this and ask a couple of questions about the data. And in the process, I'm going to show you why there are limitations with setting up panel data in this way. So first question we'll ask is just, are countries drinking more coffee in 2019 than in 1999? And if we have this data set, we can answer this question. The way we would think about this is we have many countries, and these countries are in our data set at many points in time. So you can see we have Austria showing up in many different years. So coffee consumption per capita across time. And then we have the same idea for each one of our 34 countries. So maybe a first approach is to think about what we would have to do to answer whether Austria is drinking more coffee today. And part of the challenge here, the reason this is particularly challenging, is we have to make row by row comparisons. I have to compare the 1999 row to the 2019 row. And then I have to do this for every country. But we can do it. The fundamental challenge is that the data is spread out over multiple rows. So one way we could plot this data very easily is just to plot a line graph. So this is just a simple figure showing for each country the coffee consumption per capita during these 3 decades. So we have 1990 all the way up to 2019. And so what you can see here is we have coffee consumption with all of these lines for each one of the different countries. So if I were to ask you from this figure, are countries drinking more coffee today? The way you would have to answer it with this figure is you'd have to try to sort of get a general sense of which direction the lines are going. Are they going up, meaning more coffee, or are they going down, meaning less coffee? And when I look at this figure, I think it's pretty challenging to tell which direction coffee consumption is going. I see this one country, and this country is for sure drinking more coffee today. But the rest of these countries, it's a little bit unclear. Like the bottom might be going up, so the minimums may be going up, but the rest isn't particularly clear to me. So I would wish for a figure that would allow me to communicate this data more effectively. So the main point here is this data definitely communicates this. Our figure definitely communicates the data. It's readable, but it just is not very effective. So we have another kind of tool we've talked about for displaying numerical data, the histogram. So if I just take one particular year, excluding all the other data, just looking at 1999 and plotting the distribution of coffee consumption per capita across my 34 countries in this one particular year, the distribution would look like this, where we have coffee consumption on the horizontal axis, and then we just have our counts on the vertical axis. To answer the question of whether the world is drinking more coffee, we have to compare it to the second year. So we've talked about overlaid histograms, and we've talked about them generally in sort of a negative light, that they're a little more challenging to read than we would wish. But in this case, this one's a little bit better than our last example, looking at coffee consumption per capita. I'm sorry, looking at transactions by coffee shop. All these coffee examples are running together. This allows us to make these kinds of comparisons. It's better than the last one, so we can attempt to make comparisons in distribution. It turns out the answer to whether countries are drinking more coffee today, turns out the answer is easy to see with the right visualization. And in this case, I think I see a few patterns. One, there's fewer low coffee consumption per capita countries. You can see a lot of blue down here, which means that there's not a lot of counts in the low coffee consumption per capita. And then we also see that there's a lot of countries shifting up. And then there's also this spike here. But overall, this is not very easy to read. Histograms are great for understanding the distribution itself, but making distributional comparisons, we actually have a much better tool. We talked about multi-box plots in the context of time series data. Here, distributions across 2 different years with panel data, box plots are actually very effective for this. So if I were to ask you with this figure, is the world drinking more coffee? I think your answer would be much clearer. The minimums are definitely going up. The medians are definitely going up. The maximums are definitely going up. And then our Q1 and Q2 are also going up. So it looks like across the board, countries are drinking more coffee than before. And this is a much easier figure to read than the histograms. Okay, so this is nice. Box plots in general are more effective at making distributional comparisons than our histograms. So let's break this out by each one of our 5-year increments. We have each year represented in our data, but just to keep things concise, let's just break this out every 5 years. So what I've done here is I have 5-year increments between 1999 and 2019, and then just the box plot of the distributions for each one of these years. And if I were to ask you whether the world is drinking more coffee and sort of how that transition took place, you would look at this and generally observe that there's a general increasing trend in coffee consumption per capita. But I want to ask a couple of more narrow focused questions. So one question we could ask of these box plots is which years show at least half of the countries consuming less than 5 kilograms per capita. These are the kinds of questions we can ask of box plots because we observe quartiles. So I'm just going to talk through how I would think about answering this question. Firstly, I would look for the medians. We're asking a question about at least half. And then I would look for the 5 kilogram per capita line vertically. So we can see that here. We have the 5 kilogram line, and then we're just making the comparison to the medians for each one of these box plots. And we're just wanting at least half consuming less than 5 kilograms per capita. So that just means we need the median to be below 5 kilograms. So it turns out it's just these 3 years. So when the median is above 5 kilograms per capita, or below, I guess, And so what this tells us is there's this general increasing trend in the medians. Which years saw the largest jump in the median? Well, it's a little bit challenging to see, but if you zoom in really closely on your screen, you can see that we have this pretty big jump between 2009 and 2014. Okay, and then maybe another question, is the country with the lowest consumption consuming more today? Well, we can just ask questions particularly about the minimums. So if we think about the minimums and we ask this kind of question, is the minimum increasing or decreasing? It turns out that it's increasing. And then we can see some patterns about the maximums. There's nothing quite as clear. But then maybe a little bit more challenging of a question, which years did more than 25% consume less than 5 kilograms per capita? So in this case, we're thinking about the 25th percentile, which is represented by the Q1, so the lower side of the box. And so we're just going to compare this to 5 kilograms per capita. And when did more than 25 consume less than 5 kilograms? Well, we just need the 25th percentile to be below the 5 kilogram line. So in this case, that's everyone. Okay, and then another kind of question is to think about the ranges. So what's the biggest difference between the max and the min? That happens in 2004. So these are all distributional questions we could ask, thinking about how the quartiles have changed through time. But another kind of question we like to think about is how particular countries have changed. So we want to think about changes within a country through time. And that's not something we've done yet. All we've done is compare the distributions year to year. So this is a question we could ask. Where did most countries increase their coffee consumption? I want you to look at this figure, think about how you might try to answer this figure, this question using this figure. We have all the data. All the data is displayed here. Every data point for every country across every year is included in this figure. My question to you is, first off, can we answer this question with this figure? And then how might we go about answering this question? In which year did most countries increase their coffee consumption? So we know for sure that many years we're seeing an increase in all of the quartiles. But fundamentally, we can't see whether this country has increased or decreased their coffee consumption per capita. Fundamentally, what we're doing by showing the distributions and how they've changed is removing the information, allowing us to track a particular country between years. So maybe to make this even more stark, how many countries increased their coffee consumption per capita between these 2 years? So it's sort of a measure of increasing or decreasing. And when I look at this, I can see that the quartiles are increasing generally. But I could have all of the countries on the border of the quartiles increase, which would be 5, so one country for each one of the quartiles. But then have all of the other countries decrease their coffee consumption per capita. That would be 29 countries decreasing their coffee consumption per capita while still seeing the box plot shift up. So just because the box plot is shifting up, that doesn't tell us that most countries are increasing, even though sort of our intuition would suggest that it would show that. So the answer to this question is just not visible in our figure. We can zoom in and look at these 2 years specifically to see the same idea. You can sort of think about what we would need to answer this question. We would need to know where this data point went in 2019. And it generally looks like we have the core challenge is that it's very difficult and actually impossible with this figure to be able to the number of countries increasing their coffee consumption per capita. Okay, so what we want to answer this question is a comparison between 2 years for every country. And in long format, like I mentioned at the top, this is very challenging to do. We have to compare 2 different rows to each other. Very doable, but it's a little more challenging than we would like. So what we do with wide format panel data is actually just fix this problem entirely. We have, instead of representing each row year, or each row as a country and a year, we're representing each row for a country, and then each column is representing a year. So we have consumption in 1999 for Austria, and then we have consumption in 2004 for Austria as well. So each row is representing a country or an entity, and then each column is representing a time period. And for me, this is a little bit more intuitive to think about than long format panel data, although long format panel data is sort of more consistent with how we think about like cross-sectional data. If you find long format panel data more intuitive, you're probably not alone. Okay, so if we're doing comparisons between these 2 years, in long format panel data, we had to compare 2 different rows, which is challenging, where in wide format panel data, all we have to do is compare columns, which is very easy. So here's our wide format panel data. This is long format. And these 2 formats have exactly the same data. It's just we've organized it slightly differently. Different shapes, but the same information. And depending on your task, one format may be easier to work with than the other. Okay, so if I have this data set on coffee consumption per capita, I want you to spend just a second thinking about how you would visualize the answer to this question, right? We've talked about line plots. So we have time series for each one of our countries, just all put on top of each other. We could break it up by facet if we wished, but that's also really challenging to read. If we're trying to think about how many countries increase their coffee consumption between 2 years, we'd have to make comparisons to the start and end for each one of the countries, and then count up the number that are increasing. And that's very doable, but more difficult than we would wish for a figure. Either allows us to track the countries across the 2 years. So we want some measure of change between the 2 years. It turns out we have an amazing tool to allow us to do this. This is a scatter plot, and I'm just going to talk you through how we display changes through time on a scatter plot. So on the horizontal axis, I have coffee consumption per capita in 1999. So for example, this country here is consuming in 1999 just under 12 kilograms per capita. So maybe 11. And then, so we've encoded the horizontal position to represent their coffee consumption per capita in the first year. Then in the second year, or sort of second period, 2019, I have encoded their coffee consumption per capita in that year. So the vertical axis is representing the second year. So that's, what's that, like 15 kilograms per capita? So a position on the two-dimensional plane is encoding coffee consumption per capita at 2 different times, one for the x dimension and one for the y dimension. And this allows us to see relationships between changes through time for many countries. So I have all 34 countries visualized on this scatter plot. Okay, so if I'm interested in thinking about increases or decreases, I can set up a line that represents every pairing of coffee consumption per capita where we saw no change. So a 45 degree line shows every possible point with no change. So if we're consuming 8 kilograms per capita in 1999, then we're consuming 8 kilograms per capita in 2019. And if we're interested in finding all of the countries that have increased their coffee consumption per capita, all we have to do is look at all of the points above that line. So in 1999, they were consuming 8 kilograms per capita. In 2019, they are consuming more than 8 kilograms per capita. So that puts them above the line. And then the same is true for all the points under the line. So if we've decreased our coffee consumption per capita, we would be below the 45 degree line. And then here I've just used colors to encode increases and decreases. So we're going to walk through creating scatter plots in exercise 1.5. But I also want to talk to you about how we might count changes. So we're going to walk through how to create these scatter plots with wide format panel data in exercise 1.5. But I want to talk to you about how we might go about counting the number of countries that have increased or decreased. You remember our original question was how many countries have increased their coffee consumption per capita during our 2 years? And so we might be interested in just counting these countries. So visually we know how to find them, but how do we actually calculate the change? The first thing to do is to just construct a new column, which is just how coffee consumption per capita has changed between any 2 years, or these 2 years specifically. So much like we've done transformations before, we just want to create a column for change. So the difference between 29. So if we're trying to find all of the countries that have increased, we would just select the countries with a positive change. And then we just go through and count the size of the data set. So how many rows are remaining after we've filtered. So we're going to do all of this in our exercise 1.4, but I just want to talk you through a bit of the summary before we go there. So what have we done? We've introduced a wide format panel data where every time period is a column instead of including time in rows. And then we've talked about multi-box plots to compare distributions across time. We've talked about scatter plots, which are sort of this top tier data visualization tool, and then 45 degree lines to track changes through time. And then we're going to talk about filtering to count subsets in exercise 1.5. So to think about our building blocks, we have numerical variables, we have panel data in wide format for our data structure. We're going to talk about filtering, and then we've talked about multi-box plots and scatter plots with a 45 degree line. So in part one of the course, this is sort of the outline of what we've covered. We've talked about categorical and numerical variables. We've talked about cross-sectional data. We've talked about time series data. And then now we've wrapped up panel data in long and wide formats. We've talked about counting operations for bar charts and pie charts. We've talked about bins for histograms and means, standard deviations. And then we've talked about quartiles for box plots. We've talked about a real price transformation, so our first example of a data transformation. And we used that with a line plot to think about time series. And then we've also talked about multi-box plot for seasonality in time series. For long format panel data, we used a group by operation to create a summary table. We talked about multi-line plots and facets. And then just now we talked about a scatter plot, which is really just in the pantheon of great data visualization tools. So that's the big idea. There's a little bit more here as you're preparing for mini exam 1, just to give you a bit of a wrap up for what we've done in part 1. But I'm going to see you in exercise 1.5.